Okay, I've just had some chocolate and I'm ready to finish this thing. Concrete guttering links a road. Concrete guttering links a road surface and a nature strip along suburban street. The road surface and the nature strip are both shown here. Cross-section of the gutter is shown below, so that's what we've got there. The cross-section of the gutter can be represented by the function this pretty thing here, where the x-axis represents the level of the road surface and the y-axis represents the point at where the gutter meets the nature strip. Okay, so the y-axis is here, the x-axis, level of the road surface. So that's the x-axis there. Okay, cool. So, unit measurement is centimeter. Alright. Alright. So we're going to factorize that thing. So I'm going to define that as g of x. I'm going to define it as g of x like it is there. So I'm going to say, I'm going to get some new variables. I'm going to say define g of x equals. And now I'm going to write this thing, and I'm noticing that my domain is that there. So I'm going to define my, I won't define my domain because I don't actually know it, but we're going to be asked to solve for a. So let's just see what ends up happening. Actually, where the x-axis represents the level of the road surface. So if that's the x-axis, that's where the function equals 0. So we can actually solve this value here because our y-axis is here. That's one of the first things that we'll do. Okay, so we want to factorize this thing. So just on CAS, so let's define this. So define g of x 1 over 8,000, and we got brackets. X cubed minus 60x squared, x cubed minus 60x squared minus 400x plus 24,000. So really good thing with CAS is we can use it for these kind of things here. So now we're going to factor g of x, and we end up with that thing there. Okay, so that's your 1 mark. Now we want to find. Now the other thing I'm going to find out where it ends. So I'm going to say solve g of x equal to 0 for x. Negative 20, 20, or 60. Okay, that's a bit of a pain. So let's go back to our thing. Negative 20, 20, or 60. So this will go from 0 to 60. So that's what we're going to find out the domain now. To find that, given 0 is less than or equal to x, which is less than or equal to 60. That's what we end up with there. Okay. On instead of axes below, sketch your graph of y to do. Clearly indicate on your graph the coordinate of any axis intercepts, coordinate of any turning points, express coordinates 1 decimal place, and the coordinates of the endpoints. Okay, so we're going to graph that thing. And we're going to say there, and then we're going to say g of x. So we end up with there, and we're going to go out to 60. Now we're going to change our window settings. We're at, because it's negative, say, negative 2, and we got to say 65. And everything else seems like it's okay, but let's see what happens. Okay, there we go, there's the thing. So we want any axis intercepts. So now we want our 0. 20 and 0, menu, analyze graph. Once again, where's the other 0? We'll have here 60 and 0. And then we want to find our maximum point. Analyze graph, maximum. Lower boundary, upper boundary, having 0, 3, which is also our endpoint. Analyze graph, minimum. 41.3 and negative 3.1 because it says to 1 decimal place. So that's what we've got there. So that's the way we'd be able to hence write down a value of a which we've got. That's 60. What is the range of this function? G, explain the values to 1 decimal place where appropriate. So our range, well, we're starting at a maximum here of 3. We've got a minimum of negative 3.08. So that's our range. Negative 3.08 or negative 3.1 out to 3. And they are both inclusive. What is the maximum height that the water collected in the gutter can reach before it floods onto the road? Oh no. So that's the road surface. What's the maximum height? Is that right? what is the maximum height that the water collecting in the gutter can reach before? So that would be this value here. It's a bit weird, doesn't seem right. So that would be 3.1 centimeters. Okay, that didn't seem about right, but that'll do. A straight stick of length 30 centimeters is put here onto the gutter. It rests in 2 points on the gutter, which a graph of y equals g of x coincide with the points -40 and -3, and then 60. So it attaches itself there. Find the length of stick that protrudes, sticks out. So we want to find this length here. Okay. So it's 30 centimeters. And it rests at 40 and -3, 60 and 0. Okay. So it's 30 centimeters long. We've got to work out the distance between here and here. Okay, so that's just Pythagoras. So 40 to 60 is 20. We're up to 3. So I'm going to find the square root of 20 squared plus 3 squared. Square root of 409. So square root of 409 there, as that distance there, if it's 30 centimeters. So I am going to 3.0. So 22. So we'll have 30 minus that, and we end up with 9.78 centimeters. Whatever one is less, so 9.8 centimeters. And that's it. 2014 Technical Objective Semester 1 exam finished. Thanks for watching.